Okay, so we are starting now. We're getting close to guided notes question 15. We're in lesson 1.3, temperature and motion. So for our warm-up activity, we want you to explore the simulation and mess around with it. Add multiple samples and change their energy levels. Look at the run section and analyze sections. Turn on and off the view kinetic energy and view energy transfer. So as you can see right here in your guided notes, you have a link for your sim right there. So we want you to hop on and start with that. Okay, so start with the link right above guided notes question 15 and go ahead and explore the sim. You can pause the video with this on your screen so you can take a second to do that. Okay, so moving on, we've got simulating hot and cold water. Okay, so again, we're using the sim. Okay, we're going to use the replay button in the bottom left to show the graphs running over time. So let me go ahead and put this in slideshow mode so that I can play this video for you.
This is the thermal energy sim. You'll use it to learn about temperatures and energy in different substances. To begin run mode, use the Add Sample button to add a small, medium, or large sample of a substance. You'll see a model of your sample here in the box. You can add energy to the sample using the plus sign or remove energy using the minus sign. Notice that when you add energy, a hot coal appears below the substance. When you remove energy, an ice cube appears below the substance. In the top right, you can turn the View Kinetic Energy toggle on to see the kinetic energy in the sample. The higher the kinetic energy gets, the brighter yellow the sample will become. Use the controls at the top right to pause the sim, change the speed, or reset and start a new run. Let's add another sample using the Add Sample button. You can add or remove energy from each sample, or drag the samples together. When you put two samples together, you can turn on the View Energy Transfer toggle to see the transfer of energy between them. Press Analyze to track how your samples changed. You'll see graphs showing changes in thermal energy over time and temperature over time, with a different line for each sample. You can view one sample at a time, or both. Use the Replay button in the bottom left to show the graphs running over time. If you make a mistake or want to start over, go back to Run and press the Reset button in the top right.
Okay, getting out of that.
This is the thermal energy sim.
Okay, so moving on. So guided notes question 15. Okay, what do you think the small circles in the sim represent? So take a second, answer that question. Guided notes question 15. Okay, so coming back. Guided notes question 16. I want you to think about this before we actually give you the actual answer. Okay, what do you think this word means, molecule? Okay, so think about that. And then we will give you the actual definition here in a second. Okay, so here is your actual definition. Molecule is a group of atoms joined together in a particular way. Make sure you have that down for guided notes question 16. A group of atoms joined together in a particular way. Okay. And still with guided notes question 16, we're going to give you some examples of molecules. We have CO2, which is carbon dioxide. Okay. One carbon, two oxide molecules, which is carbon dioxide. H2O is water. Two hydrogen molecules, one oxygen molecule. C6H12O6 is glucose. Then we have oxygen gas, that is O2. Okay, two oxygen molecules. Okay, H2 is a hydrogen gas that is flammable, and N2 is a nitrogen gas. So go ahead and get these down in your guided notes, question 16, as some examples of molecules. Okay. Yeah. Okay. Next one. In this unit, we will describe the smaller pieces that make up stuff by using the word molecule, okay? So here's a water molecule, okay? 2 hydrogen, 1 oxygen. So we have 2 hydrogen atoms here at the bottom, and 1 oxygen is the big red one right there that connects the 2 hydrogen together, okay? Okay. In the sim, each circle represents 1 molecule. So if you already put that as your guess in Guided Notes question 15, good job. The sim portrays molecules on a much larger scale than their size in real life. Okay. How many molecules of H2O do you think are in 1 drop of water? How many do you think are in a gallon of water? Okay, I want you to think hard about that. Okay. Here you go. How many molecules of H2O do you think are in 1 drop of water? Look at that big old huge number. Okay. A lot. How many do you think are in a gallon of water? Look at that. Okay. 126 gajillion. No, just kidding. Okay. There's a lot. Okay. More than we could even wrap our brains around. Okay. The sim shows a small number of molecules so that we can easily observe what is happening to them. Okay. That's the point of a simulation. The things around us, even very small things, are made up of billions of molecules. Okay. Key concept number 17, or key concept number 1 in this unit, but Guided Notes question 17. Things are made up of molecules or other types of atom groups. Okay. Pause the video if you need to, get that down. Awesome. Okay. So we did an experiment with some food coloring and some hot and cold water. Okay. So Guided Notes question 18, we're going back to that for a little bit. What did you observe in the investigation? What could have caused the difference between how the food coloring moved in the 2 cups? Use the words molecules of water, use the words molecules of food coloring, and use the word diffusion in your explanation. Okay, so take a second, record that in Guided Notes question 18. Think about it real hard, what we've already learned about molecules and about diffusion. Okay, now we'll use the sim to model the food coloring investigation. This will help you find evidence to help explain why the food coloring spread out differently in the 2 water samples, okay? Okay, so here's simulating hot and cold. Went a little too far. Simulating hot and cold water, you're going to use the thermal energy simulation to recreate a similar situation to the cups of water from the food coloring investigation in the previous lesson. So Guided Notes question 19 is where we are now. You have your sim link, you have your instructions right there, and then you've got 2 questions, B and C. Okay, so let's move so you can see. Here's your instructions. Okay, those are also in your notes, Guided Notes question 19. You have your instructions. You're going to open the simulation, add 2 of the same sized samples, make 1 sample hot and 1 sample cold, and then observe the differences between the 2 samples. Okay, and then here are the questions you're going to answer once you're finished with that. What evidence did you find in the sim activity? Answer Guided Notes question 19, parts B and C. Okay, so parts B and C, what do you notice about the movement of the molecules of the 2 samples? And C, explain what you discovered from the simulation about why food coloring spreads faster in warmer water. Okay, you can pause if you need to. All right, and here's Guided Notes question 20. Using the evidence that we just found from the sim, I want you to try to answer our question, our investigation question. This is Guided Notes question 20. How is something different when it is warmer or cooler? Okay, how is something different when it is warmer or cooler?